let's discuss vectors. So first thing, what is a vector? So a vector quantity has both magnitude and direction, right? So in vectors, obviously we will be discussing about the magnitude, but we should be very careful about the direction of that vector as well, because a vector quantity is one in which we have magnitude with direction, right? So problems involving forces, we'll be resolving forces in A levels. Inshallah, we'll be looking, in depth how to resolve forces and how directions are important. So problems involving forces and velocities. So we know velocity is a vector quantity. Why? Because velocity is what? It's basically speed in a specific direction. So when we're calculating speed but taking the direction as well, so it becomes velocity. So in simple terms, speed in a specific direction, right? So when direction comes in, so once again, magnitude with direction, so it becomes a vector quantity, right? So yes, uh, when you're taking speed in a specific direction, let's say 30 kilometers an hour. So, but when you take the direction, it becomes velocity. So then we say the velocity is 30 kilometers per hour. And another example could be displacements. So displacement is also pretty simple. From the origin, we take the distance, right? For example, this is the distance, and this direction we take as the positive direction, and the opposite direction we take as the negative direction. So when you're calculating distance, but obviously you're taking direction as well. So when direction comes in, then the quantity becomes the vector quantity, right? So these are one of the few examples in which we take magnitude with direction, right? So that quantity becomes a vector quantity. And it's very helpful when we use vectors to solve these problems. So it becomes very simple, right? So let's look into the first concept, how to add vector quantities. Right. Addition of vectors. So let's say we have two vectors. For example, we have a vector A in this direction, and let's say we have a vector B in this direction. So what is the rule by which we can add the two vectors or as many vectors as we have? So what is the rule? That is called the head to tail rule in simple words. And there are many different names given to this. In many books, they have also given the name as parallelogram law of forces or the parallelogram rule. So I keep it simple. So I just tell my students that it's head to tail rule, right? So I'll show you how to add vectors. So what do you mean by head to tail rules? Let's take one vector. For example, let's take this vector B. So we can see this is the starting point of the vector because it's direction in the it's directing on the other side and the arrow is pointing towards the opposite side. So that means it's ending here. This is the head of the vector, right? So this is the starting point, and I call this the tail of the vector, and because it's pointing towards the other side, so it ends here. So basically, this is the head of the vector. So I could have drawn the arrow here as well, right? I could have drawn the arrow here as well. But anyway, that is how the arrows are drawn. But we need to understand the starting point is always considered as the tail of the vector. And because it's pointing on the towards the other side, so the other end would be considered as the head of the vector, right? So again, the rule is head to tail rule. Head to tail rule, right? So what is this rule? That is how you add the two vectors. So let's take one vector. Let's take vector B. So this is the tail, this is the starting point, this is the ending point of this vector. So this is the head of this vector, right? So head to tail rule. So you want to connect another vector with that, you want to add another vector with that. So head of the first vector to the tail of the second vector. To the tail of the second vector, right? So that means head of the first vector, and with that we just simply add the other vector. So this is A. So this is the tail, and obviously it's pointing towards the opposite side. So this would be the head of the second vector. So we just simply pick this vector, and where we will place it, this is important, on the head of the first vector, right? So head of the first vector and tail of the second vector, and obviously it's pointing towards the outer side. So this is the head of the second vector. So that is how you add the two vectors, right? Uh, it could be reversed as well. For example, you want to take the first vector, this one. So what you do is you will simply pick the first vector, right? And according to the rule, head to tail rule. So head of the first vector is this, and tail of the second vector is this. So it's horizontal. So you just simply put this vector on the head of the first vector. So it's pointing outward, it's pointing towards the right. So head of the first vector, and that would be the starting point. That would be the tail of the second vector, and obviously it's pointing outwards. So that is how you add the two vectors, and the addition will be, this would be the, you can say, the resultant, and the answer you write is, because this is the starting point, this is the ending point. So you want to finish it. So this is A plus B, because the directions are same. So this will be A plus B. And similarly, you standing here, you want to reach here. So what is this? This is B plus A. So please remember that A plus B is equal to B plus A in addition of vectors. That is exactly the same. Direction, you notice, is exactly the same, right? So A plus B or B plus A, it is exactly the same. So a quick recap, how do you add two vectors? But that's pretty simple. uh, you can pick any of the two vectors. So just pick one vector, but please remember that head to tail rule, that you will join the tail of the second vector with the head of the first vector. And you can add as many vectors as you can. And the resultant will be from the starting point of the first vector to the ending point of the second vector, and just simply add as many vectors are there in the path. So this is B plus A. So the resultant will be B plus A. So this was the starting point, and this is the ending point. So the vector, the resultant was A plus B, right? The direction is same. So the resultant will be A plus B, right? So I hope the addition of vectors is absolutely clear. Let's look into another example. Let's take a look at this question. Find each vector in terms of A and or B. So either the answer could be in terms of A only, or B only, or in terms of A and B, right? So let's solve the first part. Find the vector BA, right? So we know that AB vector is A. That is in this direction, right? So that means we need to find the vector BA. So B to A, the magnitude will be the same. The magnitude, obviously the length would be the same, but direction from B to A would be opposite to the direction of A to B, right? So B to A, the direction will be opposite. So we just put a negative sign with that. Once again, A to B vector is positive A, and the direction is positive A is considered from A to B, right? So this direction is positive. So when you're taking vector BA, better please remember the magnitude is A, the length is A, the length is same, right? The magnitude is same. B to A only direction is reversed. So we are taking this direction now. So that would be minus A, right? Because positive A is from A to B. So from B to A, the vector will be negative A. Magnitude will be A, the direction will be negative. I hope this is pretty simple. Okay. Let's look into the second part. The vector AC, right? So we have to find AC, right? It's pretty simple. You're standing at A and you have to reach till C. This is your starting point, right? And this is your destination. I call this destination. So you have to reach to this point, right? So what are the known paths, the known vectors? Because this is unknown, we cannot directly jump from A to C because we don't have any path, anything given in this. So we would take a longer route and known path. I call this the known path. So again, this is your starting point and you have to reach till point C. So let's start a journey from the starting point. So let's add all the vectors in the way. So, okay, let's write a path first. So A to C is what? You starting from A to B. So you will reach from A to B, right? Plus. Then from B to D, plus. You've come at D, then D to C, plus D to C, right? So that would be your path. Once again, you have to find the vector AC. So this is unknown. Obviously, nothing is given. So you would take the longer route and the known vectors you'll add it on the way, right? So this is your starting point. You're standing here. So you start your journey from here, right? So we'll move in this direction. A to B, vector is given. You've reached B. Then B to D, you'll add the second vector. You've reached D. Then D to C, and you've got to your destination. You've got to the point where you wanted to reach. So just simply add all the vectors. So what is AB? This is A plus. Let's write it here DB, right? Part C. So AB vector is what? That is A. B to D vector, that is B. The direction is same. Now you have to be careful. So C to D is 2A in this direction. But you want D to C vector, right? D to C. So magnitude will be the same, but sign will be reversed. So this will be minus 2A. So this will be opposite direction. You just put a negative sign. So this will be minus 2A. I hope this is pretty simple. Now don't forget to simplify the terms, the like terms. So B, what is plus A and minus 2A? That is minus A. So B minus A is the answer to the vector AC. I hope it's pretty simple. Okay. Now let's look at this DB. Okay. So we know B to D is vector B. The magnitude is B. But D to B will be, the direction will be opposite. Magnitude will be the same. So this will be minus B, right? Because B to D is vector B. When you reverse the direction, just the sign will be opposite. Magnitude will be the same, right? Clarity? Let's move on to the next part. So AD. How do you find the vector AD? Again, this is the vector you want to find the A to D, right? You want to find this vector. So again, this is your starting point, and obviously this is the destination. This is the ending point you want to reach, right? So you'll start from here and you'll try to take the simplest route possible, the available simplest route. So I could see this is my starting point. You have to start from A and you have to end at D. So A to B, that would be my first vector. Let's write the path first. So A to B will be my first vector and then B to B. So this is my destination plus B to D vector. So that is how you add vectors. I hope this is pretty simple. So what is A to B? This is positive A. Direction is also same. B to B, this is positive B, right? So that is the vector AB. So I hope you've learned how to add vectors. It should have been 1 plus 1 for you.